Today I am going to explain about gaseous state. Gaseous state and gas laws. Gas laws. So, in my last video, I have already explained about intermolecular forces and thermal energy, right? So, what is intermolecular forces? Intermolecular forces means there is repulsions and attractions, right? Repulsions and attractions. So, these forces between the interacting particles present in the matter. The forces between the forces means attractions and repulsions, right? So these forces between the interacting particles present in the matter. So particles means molecules, atoms, whatever it may be, right? So intermolecular forces means the forces are between the interacting particles, right, present in the matter. So thermal energy means this energy is due to the temperature, right? Temperature. Thermal energy means due to the temperature results in movement of particles present in the matter. Movement of particles present in the matter, right? So today, what is intermolecular forces versus thermal energy? So relation between them. So intermolecular forces always keep the molecules together. Keep the molecules together, right? Keep the molecules together. Intermolecular forces, attractions or repulsions, whatever it may be, but keep the molecules together always. And thermal energy molecules tends to keep them apart. Keep them apart means separate the molecules. When we apply heat to it, some temperature to the system, then definitely what happened in the matter? What happened? Molecules are separated, obviously, right? So thermal energy, due to the thermal energy, molecules are keep them apart. That means separated. Keep them apart means separation, right? So intermolecular forces are keep the molecules together, and thermal energy keep them apart. That means separate the molecules. This is the difference between intermolecular forces and thermal energy, right? So this is the relation between the intermolecular forces and thermal energy. So intermolecular forces are high in solids, right? I have already explained about that. So again, you can see here increasing order of intermolecular forces in physical states, right? Intermolecular forces are increasing. That means in solids, intermolecular forces are very high. Whereas coming to the thermal energy. This is the order of thermal energy present in the physical states. That means in gases, thermal energy is very high, right? Quite opposite. So intermolecular forces are high in solids and thermal energy results high in gases, right? So next one, whereas coming to the gaseous states and gas laws, right? So behavior of the substances exist in gaseous state. Gaseous state means the behavior of substances present in the gaseous state. Present in the gaseous state. Gas state, right? So gaseous state under normal conditions of temperature and pressure. So gaseous state and gas laws means behavior of the substances present in the gas state. And gas law also explains about behavior of the substances present in the gas state at the normal conditions of temperature and pressure, right? There is some gas laws also there. There is some gas laws. So this gas laws explains the behavior of the substances present in a gaseous state at normal conditions of temperature and pressure, right? So some gases under normal conditions, so it exists as gases. In periodic table, we have to observe in periodic table some elements are exist as gaseous state, available in gaseous state. What are the elements in periodic table? Hydrogen, right? So helium, neon, obviously noble gases, right? Hydrogen, helium, neon, argon, krypton, xenon, radon, right? And also nitrogen, oxygen, fluorine and chlorine, right? So these are the elements present in the periodic table or exist as gases. Exist as gases, right? So generally gases are highly compressible, right? Highly compressible. We can compress the gases at any pressures, at any pressure and temperature. That means gases are very compressible, and gases are shows pressure equally in all directions. All directions. Gases have much lower density than the solids and liquids, right? Density means lower density. Lower density than solids and liquids. Density means weight. Gases are lower weight than the solids and liquids, right? So generally gases mix evenly and completely in all proportions. Gases are generally mixed with any. So gases mix with any, whatever it may be, but completely and evenly in all proportions. Here you have to remember 3 points. Gases are very compressible and it having lower density than the solids and liquids, and gases mix evenly and completely in all directions and proportions, right? So these are the main points about gases. Main points about gases, right? So the behavior of the gases, so at temperature and pressure conditions, so for these purposes gas laws are proposed. Gas laws are proposed. So these gas laws are generally result of research carried on several centuries. That means many scientists are carried the research about gas laws for many centuries. Right? So in that gas laws mainly we are studied about generally Boyle's law, right? Boyle's law, Charle's law, right? Charle's law. And the next one is Gay-Lussac's law and Avogadro's law. Avogadro's law, right? So these are the laws in this states of matter chapter, right? So generally Boyle's law, Charle's law, Gay-Lussac's law and Avogadro's law, right? So first of all we are going to study about Boyle's law, okay? This Boyle's law was made by Anglo-Irish scientist Robert Boyle in 1662 year, right? So this Boyle's law was proposed by Robert Boyle, right? This Boyle's law, Boyle's gas law, states that pressure and volume this law states that a gas pressure and volume inversely proportional. Pressure and volume of a gas inversely proportional when temperature and quantity of gas kept constant. That means if pressure and volume inversely proportional, here you have to observe pressure and volume is inversely proportional when temperature and quantity of gas kept constant. That means P is inversely proportional to 1 by V, inversely proportional to V. That means pressure is inversely proportional to volume at constant temperature and mass. Quantity of gas, that means mass, right? Constant temperature and mass. Pressure is inversely proportional to the volume. That means if pressure is increases, volume is decreases. If pressure is decreases, then volume is increases. Inversely proportional, right? So this proportionality can be converted into the equation. We have to add K here. This proportionality can be removed by adding K, constant. Proportionality constant, right? So P is equal to K 1 by V, right? K means proportionality constant, right? So PV is equal to K, right? PV is equal to K. So product of the initial pressure is P1 and V1 is initial volume, right? And P2 is final pressure and V2 is final volume. So in that case the equation will be P1 V1 is equal to P2 V2. So P1 V1 is equal to K and P2 V2 is equal to also K, whereas K is constant, right? So P1 V1 is equal to P2 V2. So the example for the Boyle's law is balloon. So what is Boyle's law? Boyle's law states that pressure and volume are inversely proportional when temperature and the mass is constant. Simply, pressure and volume is inversely proportional at constant temperature and mass, right? So we have to remove the proportionality symbol. That's why we are adding proportionality constant here. K. P is equal to K 1 by V. So PV is equal to K. So final pressure and initial pressure. That's why I am writing here P1 V1 is equal to P2 V2, right? So this is Boyle's law. You have to remember one thing: when the pressure is increases, volume is decreases. pressure is increases, volume is decreases at constant temperature, right? So when we observe one thing, so when a filled balloon, so right, this is balloon, consider it is a balloon. When we squeeze the balloon, that means when we squeeze the balloon, the volume occupied by air inside the balloon decreases, right? When we squeeze the balloon, then definitely the volume of the balloon, that means the gas present in the balloon, inside the balloon, or that means the volume is decreases, right? Decreases. That means when we apply pressure to the balloon, then volume is decreases. That's the Boyle's law, right? So when we squeeze the balloon, then what happened? The inside the gas, the volume of the gas is decreases. We are applying pressure, that's why volume of the gas is decreases, right? You have to remember one thing only: pressure is inversely proportional to the volume at constant temperature and mass. This is Boyle's law, right? The next one is Charle's law, right? Charle's law states that volume of ideal gas is directly proportional to the temperature. Volume is directly proportional to the temperature at constant pressure. The Charle's law was proposed by Frenchman Charle, right? So Charle's law proposed by Charle. He is the French citizen, right? So he states that volume of ideal gas is directly proportional to the temperature at constant pressure. Right? So that means he explains how gas expands when temperature increases, right? He explains how gas expands when the temperature increases, right? If temperature increases, obviously volume also increases. Why? Because it is directly proportional, right? V is directly proportional to T. So when V increases, obviously the temperature is also increases. If we increase the temperature to the any gas, then also definitely volume also increases. In generally, you have to think here. So generally, in a beaker, there is some gas is present in it. Okay, some gas is present in it. When we apply temperature to the beaker, then definitely what happened? Temperature to this beaker, then the gas present in the beaker or expanded. That means the volume is increases. When we give to the temperature to it, obviously the volume of the gas is increases. So this is Charle's law, right? So volume is directly proportional to the temperature at constant pressure, right? So if we compare this law applicable to the ideal gases only, ideal gases, right? So held at constant pressure, This law only applicable to the ideal gases at constant pressure. These are the conditions for the Charle's law. These are the conditions for the Charle's law. But so temperature and volume is keep changing, right? Keep changing. This gas is applicable to the ideal gases at constant pressure, but volume and temperature is always keep changing. Always keep changing, right? So if we raise the temperature, then obviously volume of the gas is also rises, right? So, and the next one is, and the temperature, this temperature must be in Kelvin. Temperature must be in Kelvin, not Fahrenheit degrees and Celsius degrees, right? Must be in a Kelvin. In case the temperature in Fahrenheit degrees or Celsius degrees, definitely we have to convert into the kelvins. We have to convert into the kelvins. Like we have to convert the Celsius to kelvins. Definitely what we have to do, we have to add the 273. We have to add the 273 plus temperature. Using this formula, we can convert the temperature from Celsius to Kelvin. But in Charle's law, the temperature must be in kelvins only. Kelvins only, right? Kelvins only. So we have to convert the temperature by using this formula, right? So 0 degrees means 0 degrees on Kelvin scale. On Kelvin scale means absolute zero. Absolute zero. Absolute zero. Right? Zero degrees on Kelvin scale. Kelvin scale, 0 degrees means absolute zero or minus 273. Right? So these are the conditions generally for Charle's law. So ideal gases applicable to the only ideal gases at constant pressure, but volume and temperature keep changing, right? And temperature must be in a Kelvin scale. In case the temperature in Fahrenheit degrees or Celsius, we have to convert by using this formula, we have to convert the temperature, right? So then generally V proportional to T, right? So the initial volume V1, initial temperature T1 is equal to the final volume and final temperature, right? So V1 T1 is initial volume, initial temperature. Vf and Tf means final volume and final temperature, right? So V by T is equal to K generally, right? So that means V1 by T1 is equal to also K, proportionality constant. Proportionality constant. So V proportional to T, that means we have to remove the proportionality. That's why we are adding K. So V by T is equal to K. That means V2 by V1 is equal to T2 by T1. T2 by T1, right? V2 by V1 is equal to V1 means V2 means final. V2 means final volume, right? So V2 by V1 is equal to T2 by T1. So then what happened? V1 T2 is equal to V2 T1. So this is the equation for the Charle's law. This is the equation for the Charle's law, right? So V is proportional to T. You have to remember. So V by T is equal to K. K is proportionality constant. So this law, Charle's law, is generally the example for the Charle's law. So in cold weather, generally in cold weather, cold conditions, cold weather, in winter also, so capacity of human lungs is decreases. This is the example for the Charle's law. Why? Because I am saying V is proportional to T. When temperature decreases, volume of the gas is also decreases, right? So in cold weather, what happened? Temperatures are drops, right? Temperature is very less, very cold conditions, right? So that's why capacity of human lungs also decreases. So all of you know about the lungs working, right? So the capacity of human lungs is decreases. So temperature is decreases. That's why volume of the gas, that means the we are breathing, right? So the capacity of human lungs is decreases. That's why it is difficult for people to go to jogging in winter, right? Jogging is very difficult in winters. Why? Because V is directly proportional to temperature. Temperature drops at cold conditions, that means winter. That's why it is the capacity of human lungs also decreases. That's why jogging is difficult at winter seasons. This is the example for the Charle's law. Right? Thank you for watching.